Okay, so the description for this one, it's at the back, it's not with the X, so it'd be a vertical translation. Are we allowed to short form anything? Nope. For what? Mix up. And then our mapping, if I have an up, it moves my y. It's also not with my x, so I know it moves my y. So my x is going to stay the same, and my y I'm going to add 4 to. Now this one, I have a vertical translation. It's at the back. It's not with the x, so it's a vertical translation. 8 units down. And then we have our mapping, which is x, y becomes x and y minus 8. And then this one, we have both. We have a vertical translation. You could have listed horizontal first, doesn't matter. Vertical translation. Four units what? Up. So I know my mapping is going to be x, y becomes something, y plus 4, because I'm moving 4 units up. And then I have a horizontal translation. Seven units what? So how do I move next left? I subtract 7. Now we're going with a little bit of replacement notation. So replacement notation literally means you replace it. So you go to the x and you're like, not today. You take the x, you rip it off your paper, throw it behind your head, you grab the x plus 2, you viciously toss it back on that paper, and magic happens. That's replacement. Okay? So here it says, what happens to the graph of the function y equals fx? So I need an original function that I can rip values off of it, toss over my head, and replace back in with what I need, right? So here it says, if y equals fx, if the following changes are made to the equation. So I want to rip x off the page, and I want to throw back in x plus 2. That's all that replace means, right? So my original equation is y equals f of x. Well, I want to take that x, I want to rip it off the page, I want to toss it over my head, and I want to replace it with x plus 2. We're basically just using function notation in grade 10. When I gave you f of x basically in grade 10, that's all you did. You took the x, you ripped it off the page, and you replaced it with whatever they said, x plus 2. Okay? Now this one's a little bit dicier because we have y equals f of x. Well, I want to rip the y off. I don't want to put the x back here, right? I want to take the y, I want to just shot put it that way. Shots off, that's football. I want to shot put it this way. I want to rip it off, and I want to replace it with y minus 8 equals f of x. Now before I do my description or my mapping, what should I do to this one? Yeah. Add the 8 over. So we always want to have it in y equals, so we're not going, okay, well, it's over there, so I do the opposite. I want to have it all in that, it's not an equal sign. I want to have it all on the right-hand side. So, this one is going to be a horizontal translation. Two units left. Because it's with the x, it affects the x. So I know my xy is going to become something comma y. The y is not going to change because nothing's affecting my y, right? But if I want to move 2 left, I take whatever my x is and I subtract 2 from it, and that will move every single one of my points left to left to left to left to left. Right? Correct, I should say, not right. This one is a vertical translation. 8 units what? Up. We take what it is if we get it into y equals. And so we have xy becomes, my x stays the same because my x is not changed. And then I go y plus 8. Okay, this one here, they give you a point. The point is 2, negative 3, a coordinate. And it lies on the graph of y equals f of x. So it lies on the original graph that has not been changed. We agree? State the coordinates of the image of the point under the following wait a second, it's moving a point. What should I immediately do? Move a point, use mapping. Move a point, use mapping. Move a whole bunch of points, use mapping. Right? Now, this has the stupid little f in it. I don't think it's actually stupid, but that's what you guys all think, so I'm going to use your words. It has a stupid little f in it. Why is the stupid little f there? What is this just? It's a function. It's saying the function is moving blah, right? It's just another way of showing how the function moves instead of using words. So normally last year we would have said a vertical stretch by a factor of blah, horizontal translation blah, vertical translation blah, reflection in the x blah. And then you'd have to move it, correct? And it was always in words. Now they can give you the transformations in an equation format. So when they have the f, they're saying, hey, f is moving blah. Okay? So what do I have to do first with this one? Get the 8 on the other side. So try A and try B. We're moving coordinates. We're going to use mapping. So here we're going to go y equals f of x minus 8, and I'm going to do mapping. So x, y becomes, x doesn't change because there's nothing with my x, and I'm going to subtract, comma, and then I'm going to subtract 8 from my y because I'm moving 8 down, and then use my mapping. You have to use it properly. Do you see how I have brackets, arrow, brackets with a comma in between them? It has to look like that. You can't just, like, I don't know, write it how you feel. It's not like a feeling. It's not like an essay of how you feel. It has to be formatted correctly or they give you no marks. It's just a sad day. So then we put the original point here. 2 and negative 3 becomes 2 comma negative 3 minus 8. So it becomes 2 and negative 11. I've kind of rounded it.
Have to do that step.
Yep. Do it now because you're not going to be given something this easy. You're going to be given something like from the next 3 lessons combined together, which isn't this easy. So just practice for now. Okay, this one, we have x, y becomes x plus 7, because we're moving 7 right, y plus 5, because we're moving 5 up. So here we're going to get 2 comma negative 3 becomes 2 plus 7 comma negative 3 plus 5. So 2 comma negative 3 becomes 9 and 2. Then this one we're doing the equation. So horizontal translation, 5 units left. So that's going to affect my x because it's horizontal. So I'm going to get f. And if I want to move left in my equation, what am I going to have to do? Add. Because remember, there's that hidden negative sign in there. And if this is actually left, you could just do this. You could go fx minus minus 5. And what does that actually become? X plus 5. So that's the reason why it changes. So you could show that step for every single time, minus and minus. Now, vertical translation 3 units up. We could go y minus 3 equals f of x. You can put it on this side. Or you can go y equals f of x plus 3. It doesn't really matter. They're the same equation. So had you wrote either, I'd have to give you marks. And then a horizontal translation, m units right. We're going to get y equals f x minus m because it's moving to the right. It's x minus a positive m. And then a vertical translation p down, so minus p. Now we're going to flip over. Okay. In each case, the graph of y equals f of x is shown. Sketch the graph of the transformations of each. We're moving not only one point, we're moving more points. When we move 1 point or more points being a graph, what do we use? Mapping. Now, I know people might be like, Lepp, I'm moving them 2 to the right. Do I really need to use mapping? For this question, no. For the fact that we're not going to just do that, yes, right? We're preparing ourselves for 3 lessons from now, not for this lesson from now, right? So I know it seems stupid when you can just move it 2 to the right. And if this was a test question, please just move it 2 to the right. But if the test question has just this, I'd be very shocked, right? Now, I think up to 3, I have to go look at the curriculum, the Standards and Exemplars document again. But I think up to 2 to 3 movements, it's just normal acceptable standard. If I put in more than that transformations on an equation, it becomes a standard of excellence question. So when you see ones with like 4 or 5 movements, that's a standard of excellence, and your test can only contain 20 to 25% of that, right? So often transformations will be nice, but they'll have like 3 movements, that's it. Because and by movements I mean stretches, reflections, and translation. So if I do a stretch and a reflect, or reflect and a translation, it's an acceptable, but if I do all 3 together, it's a standard of excellence. Stretch, reflect, and translate. So here we're moving 2 to the right. So our mapping is going to be x, y becomes x plus 2 comma y. And I'll show it for 2 of them, and then if you just want to move 2, I don't care. We're just proving a point as to what we do if it was more advanced. So this point is 1, 2, 3, 4, 5, negative 6, 0. Negative 6, 0 would become negative 6 plus 2 comma 0, which is negative 4, 0. I plot my point, and then I move on to the next one. Now there's going to be something I'm going to tell you here right away. So this one is 1, 2, 3, 4, negative 5, 1, 2, 3, negative 5, and negative 3. And it's going to become negative 5 plus 2, comma negative 3, which is negative 3, negative 3. Now, please, this is where people go wrong. A lot of people will do the graphs completely correct. A lot of people will get the coordinates completely correct, and then they connect them in some weird format that's like some weird Alex format that doesn't actually make the graph. They're just like, there's points here, I just connect, and then it's just. Now here you'd be like, left, I'm moving 2 to the right. This is not rocket science. Like I will remember, you're not going to have just moving 2 to the right. You're going to have you might have the graph inversed, which means all the x become y's and all the y's become x's. So if that happens, you have to follow along and make a path. So I draw a graph, or draw a point, connect. Now if you use just moving it by 2 right now, I don't care. After this point, we prove our point of what we'll do if it's more advanced. So this one's going to go 1, 2, it's going to move here. And then I'm going to do that. And this one's going to move 1, 2, it's going to go here. I'm going to do that. This is going to 1, 2, it's going to go here. Oops, turn that straight. So let's move 2 to the right. There's a thing called invariant points. Do you know what an invariant point is? Remember from last year, an invariant point? A point that doesn't change. So an invariant point often doesn't happen in these because you're just moving it to the right. You're moving everything to the right, so the point's going to move, right? But it will come up in some transformations, just not here. Invariant points are points that do not change. Did any of these points not change? Did any of these points remain the same? No. Some people will say, well, this one here didn't change. It's still on the same point. It did change. It used to be that one, right? So just because the point still exists doesn't mean it's invariant. Still exists if it moved and became it is not invariant. Invariant means it was there, I did some stuff, nothing happened, it stayed the same. Now where does that happen? Well, if your y or your x is 0 and you multiply it by something, it will stay 0. So it's often x and y intercepts that will be invariant in some instances, right? Okay, this one, we're going to show the mapping. I'm going to subtract the 2 over. So our mapping is going to be x, y becomes x minus 3 comma y minus 2 because we're moving it 3 left and 2 down. Now you can plug these all in, but I'm okay with you just moving them now because you understand the mapping portion and that's all I need you to take from here. If this was on a test, I'm hoping you're not using that. I hope you're just going 3 left and 2 down. So 1, 2, 3 left, 2 down, somewhere over here. 1, 2, 3 left, 2 down, connect. 3 left, 1, 2, 3, 2 down, connect. 3 left, 1, 2, 3, 2 down, here. Oops. 3 left, 1, 2, 3, 2 down, here. Okay, this one, I want you to state the coordinates of the image, but I also want you to tell me the transformations that have happened. So now, if I give you mapping, can you state transformations, not just from equations? So I want horizontal translation, blank units, blank, right? Whatever. Horizontal translation, 7 units to the what in this case? Left. Remember, words and mapping are the same. Words and mapping are the same. So I always do this with words and mapping. Words, mapping, in a heart. Because they're the same. If I say the words and I say I'm moving left, in mapping I'm subtracting. If I say in the words I'm moving up, in mapping I'm adding. They're the same thing. Mapping is just literally taking the point and moving it. Words are saying this is what I'm going to do. So words and mapping, if it's a minus 7, I'm moving 7 left, right? I'm taking that point and I'm going and I'm moving it 7 left. So I want the words and I want the new point. Try that out. And then here I want you to describe, I want you to try 7. Okay, so here, if we go to do moving our point, we would just plug it in. So we'd have negative 3, 5 becomes negative 3 minus 7, 5 plus 4, negative 3, 5 becomes negative 10, 9. And our transformations will be a horizontal translation, seven units left, because I'm taking the x and subtracting 7. And then a vertical translation, 4 units up. Words and mapping are the same. Mapping says I take my x and I subtract 7 from it. If I take my x and I subtract 7 from it, I am moving left. Correct? I'm moving right. You're visualizing moving left. All right. So here we have negative 3, 5 becomes negative 3, negative minus 6. And then 5 plus 1. So negative 3, 5 becomes negative 9, 6. And we have a horizontal translation. Six units left, because I'm subtracting. And a vertical translation. 1 unit up. Now these ones, it says describe how the graph of the second function compares to the graph of the first. So I look at the first one, it has an x to the 4. I could technically put the brackets like that. I could also still put the brackets like that. Has anything happened to my x? No. Do I care that it's to a 4 and I don't even know what that graph looks like yet? Nope. All I care is the only thing that shifted was this plus 3 at the back. And when I have a plus 3 at the back, I have a vertical translation. Three units up. And when I go to do mapping, xy becomes x. My x stays the same because nothing happened to it. And if I want to move 3 up, I need to take my y's and I need to add 3 to them. That moves them 3 up. This one was tricky. I have a 6. I still have a 6. I had a 3. I still have a 3. I had an x in brackets. I still have. This is the only thing that changed. See that? It's the only thing that changed. So the only thing I should state is a horizontal translation. One unit right. That's it. And then my mapping would be x, y, and if I want to move it 1 to the right, I need to add 1 to all my x's. So don't fall to the other numbers. Make sure you check comparison-wise what has changed. The 6 didn't change, and then minus 3 didn't change. This one here, I have an absolute value x. That's one of those V graphs. Remember we did them last year? Do we even care that it's a V graph? Nope. We care what's changed. So here I have an x in brackets, technically absolute values. Here that's changed, and so is that. So I have a horizontal translation. Six units right, and so is the opposite. And in my mapping down here, I'm going to be moving 6 units right. How do I move an x 6 units right? I add 6 to it. My vertical translation, two units up. How do I add 2 units to it? I add y plus 2. This last one is irrational with a radical in the bottom. It's kind of crazy. I don't care. All I care is if something's with the x, it affects the x. If it's not, it affects the y's. I had a root x. I now have a root x plus 1. So I have a horizontal translation. The great thing about this unit, doesn't matter, it never changes. Horizontal translation, 1 unit what? If it's x plus 1, I'm moving it 1 unit to the left. Doesn't change. So my mapping is going to be x, y. My x's are moving to the left one, so I have to subtract 1 from all my x's. Then I have a number just floating at the back, so that's a vertical translation. Three units up. And if I want to move my y's up 3 units, I'm going to go y plus 3. Then I'm actually going to get you to bypass the next page and go to example 10 so that we can move the harder ones. And then you have time to work on homework before the class is over. So we're going to go here. So here we have y equals root x is a radical function. So that's your basic radical function. Starts at 0, 0, 1, 1, 2, 2, da, 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 da. It looks like this. The parent function of the square root of a radical function just goes like this. Then I go 0, 0, then I plug in 1, 1, then I plug in 4, and I get 2. And you get this graph, right? So here it says, what vertical translation? If they want to know what vertical translation, what's the only thing changing here? X or Y's? If it's a vertical translation happening and that's it. What's the only thing changing? X's or Y's? So our Y's are changing. What's it indirectly saying? Our Y is changing, but what's happening to our X? Yeah, so when our Y's are changing, it's really telling us that the X stays the same. So what vertical translation would be applied to y equals root x so that the translated image passes through 16/7? So they're asking what vertical translation would there be so that I get 16/7 when it moves? So what do I got here so that I get 16/7? So this time it's giving me the answer. What vertical translation would be applied to the original so that the translation image image means the new one, passes through 16/7? And what did I say? The y's are changing, but what does that indirectly say? So what do I know about the original point? It's 16 something, right? That's all I know. I know it's 16 something. Now how do I find out what it was? Put that into the original equation. So we have y equals root x. If we have an x, we can get a y. If we have a y, we can get an x. Well, we have an x. So we have y equals root 16. So we have y equals 4. So it would be 16 comma 4. And it's now 16 comma 7. So what happened? We got a vertical translation. What happened? We're at 4, now we're at 7. 3 units up. You try B. This time it's a horizontal. Here, this time, we know if it's a horizontal translation, what stays the same? Y. Yes. So we have 17/8. We know the y stays the same. How do I get the x? Plug it in. Good answer, guys. Great, great. Thank you. Please answer like a little quieter next time. Okay, so we have 8 root x. How do I get rid of the square root?
Square it.
Thank you. That was real. The last time it was me. I don't know if you know this, but that was me. Square it. So we get x equals 64, and then people freak out because they're like, wow, that's a large movement. There's no way. I must have screwed up. You did not. You did not, okay? You were at 64, and you're like, oh, I gotta do a mad volleyball shuffle. To 17. It's really hard to do a volleyball shuffle in sandals. Maybe that's why they tell you to put on real gym shoes in volleyball. You know? I just figured it out. Okay, so we're going from 64 to 17. So we're moving to the left. How many?
47.
A lot, also 47. So we have a horizontal translation. $47 left. Boomy boom. Boom. All right. Your homework is not a ton, because this is not the lesson that needs the training. It needs a little bit of training, but it's the next ones to come that need the more training. All right. So we did the last unit, and now we're doing the first unit. Then we're going to do the ones in between. See how that works? It's crazy. I do thank you. We're literally just like, we want the bookends to be happy, and then we can make the other things on the inside happy. Don't worry, we're not going to Unit 2 next. We're still kind of like, we're just feeling out the book. Don't worry, don't fret. We're not going to start following order or anything. I know, it could be...
I think we're going to do 3. So we're going to 6. Trigonomic identity.
I think
Trigonometric.
we're doing 3.
Really? I was right?
Yes.
Yeah, I think most classes have said 1 and then 3. Maybe we just won't do Unit 2.
We do. Still do it. Don't fret. We still do. It's just 2 lessons out of the 3, so it's lumped with other units, because that's crazy if you did 2 and then 1 to 10. Okay. So, page 12, I want you to do 3. 4C. 5A. 7. There's no other parts to it, so I can't say like 8. There is enough time. I know there's only 14 minutes, but if you work hard, you'd probably do that in 10.